This video is a video on using the chain rule to find the derivative of transcendental functions, that is at least trig functions as well as e to a power. I think this page is in your packet. These examples may already be in there, but if not, you can copy them down. And this is just to supplement what we do in class to give you another opportunity to take a look at these problems at your own pace. So let's get to it. We're going to find the derivative of these problems again using the chain rule, because these are composite functions where there's an inside function and an outside function. So let's take a look at problem number 5. In problem number 5, the first thing I'm going to do is rewrite this as 6 cosine of x to the second power. So remember from pre-cal that when you have cosine squared, that what it means is the cosine of the angle quantity squared. We need to identify the inside and the outside functions. So the outside function is the power and the inside function is cosine. Don't be distracted by the 6. 6 is simply a coefficient that we'll just bring along. So when we apply the chain rule, we'll take the derivative of the outside. So I'm using the power rule. 2 times 6 is 12 of the quantity. Remember, you bring that along to the first power. Now, of course, you don't have to write that to the first power, but I'm just showing that for emphasis that we are applying the chain rule. All of that is the derivative of the outside. Now I'm going to take the derivative of the inside, which is cosine, and the derivative of cosine is negative sine x. So as far as cleaning up, the only thing that I would do is move the negative out front. I get negative 12 cosine x sine x. And that is the derivative using the chain rule with a trig function. Problem number 6, I wanted to highlight the difference between what you see here. Notice this time that the power is on the angle. It's not written up by the function. So this time the angle would be raised to the 5th power, and then we would take the cosecant. Notice in problem number 5 that the power was written on the trig function, meaning that the whole quantity was to that power. So make sure that you understand the difference between those two expressions. So in this particular case, the outside function is the cosecant and the inside function is the angle. So when we apply the chain rule here and find the derivative, we take the derivative of the outside. So the derivative of cosecant, negative cosecant of the angle, so negative cosecant of the angle of x to the 5th power, cotangent of the angle x to the 5th power. So all of that part right there, that's the derivative of the inside, because that's the derivative of cosecant. Then we're going to take the derivative of the inside. The inside is the angle, and the derivative of x to the 5th is 5x to the 4th. As far as cleaning that up, I'll move the negative 5x to the 4th in front. Whoops, negative 5x to the 4th, cosecant of the angle, cotangent of the angle. And again, that's using the chain rule with trig functions. So that's your final answer for that one. Alright, let's take a look at the next one. In problem number 11, notice now we have an e function, an exponential function. Now we already know that when we find the derivative of e to the x, we get e to the x, because that's our favorite function in the world. The only difference here is that this function is e to the 1x. Here I have e to a power other than x, and sometimes people think of this as taking the derivative of e to the u. And by the chain rule, when you take the derivative of e to the u, e is kind of like the outside function, and u, the power, is the inside function. So when we take the derivative of e to the u, we get e to the u, just like the normal pattern, multiplied by du, or u prime, and that's the chain rule. So this would be the derivative of the outside, and this would be the derivative of the inside. So when you're taking the derivative of e to the u, you might want to think of it as e to the u du, or e to the u prime. Alright, so let's take a look at number 11. Again, the outside, think of it as e, and the inside is the power. So when we find the derivative of e to the power, we get e to the power, or e to the u, times the derivative of the power, which is 3. That part is the derivative of the inside because the power is the inside. And in cleaning that up, we get 3e to the 3x minus 7. So not real hard. Number 12. Notice we have e to a power, and this one's a little bit more complex because there is the e, which would be the first, that's the outside, and then we have a power on the power, so that would be the second part, and the most inside function would be the 3x squared plus 1. Alright, so let's see how that works out. The derivative of this function, remember when you take the derivative of e to the u, you get e to the u. U is referring to the power. Let me get rid of that 1 right there and get it out of my way. So we get e to the u, so pretty much stays unchanged. Du, or the derivative of the power. Now remember, the power has a power on it, so we're going to apply the chain rule again. So I'll have 3 of the quantity 3x squared plus 1 to the second power times the derivative of the inside. So the derivative of 3x squared would be 6x. So that's my e to the u. And back here is my du, or the derivative of the power. E to the power times the derivative of the power. In cleaning that up, I would have e to the 3x squared plus 1 to the third. 3 times 6 is 18x times 3x squared plus 1 squared. And by the commutative property of multiplication, you can move the 18x out front, or it doesn't really make it better or worse. But again, when you find the derivative of e to a power, you get e to the power times the derivative of the power, or another way to think about it is e to the u du. Alright, let's take a look at a couple more problems. Number 8, notice that the power is written on the cosine, so we're going to do a rewrite before we find the derivative, because this is the same thing as the cosine of 3x to the 1/2 power to the 4th. So notice I rewrote the square root of x as x to the 1/2 power. The derivative, I'm going to do the power rule, so I have 4 of the quantity. This is the part where I leave the inside alone, to the 3rd power. That's the derivative of the outside. Now secondly, I'm going to take the derivative of the inside, which is cosine. The derivative of cosine is negative sine of the angle. And then lastly, the derivative of the angle itself is going to be 1/2 3x to the negative 1/2 times 3. So this was really loaded with the chain rule. So let me kind of walk back through that to make sure you got it. The most outside function is the 4th power. So the first thing we did is we found the derivative of the outside and we decreased the power by 1. The second thing we had to find the derivative of was cosine. So I'll say this is number 1 derivative. This is number 2 derivative, because the derivative of cosine is negative sine of the angle. And then the third thing I have to find the derivative of is the angle itself, which again involved the chain. But you know what? I just realized that I made a mistake here. So let's back up. I'm glad I caught that, because I did the derivative of the angle itself wrong. Alright, so let's pick back up right here. The derivative of cosine is negative sine, but the derivative of the angle, let's pick the pen back up here. The derivative of the angle is going to be 3/2 x to the negative 1/2 power. When I did it before, I was treating this as the 1/2 power was on the quantity 3x, but it's not, so that's just a simple power rule. Hope that did not confuse you, and I hope that my correction has cleared that up for you. I was just reading the power as a quantity instead of only on the x. Now, as far as cleaning it up is concerned, probably what I would do, there's a 2 back here that can divide into this 4, and I can take all my numeric coefficients, so I'll have a 2 times a negative times a 3, which would give me negative 6 x to the negative 1/2 power. Then I would just have cosine of 3 square root x times sine of 3 square root x. And hopefully I did that correctly. I don't see a mistake. But that's how you find the derivative using the chain rule. You just have to be careful, just like I did. You have to go back through your work and look for any kind of careless mistakes that you made. The chain rule is just taking the derivative of one link of the chain, and then the next link of the chain, and then the next link of the chain.